Tiende pamoja ni mtima umo. 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 Tiende pamoja ni mtima.
Hello guys, and welcome to the program. My name is Kasonde, math teacher from Nangongwe Secondary School, and you are watching MTN Teleschool. Earlier on the program, we looked at part 1, or the first part of our paper. We solved question number 1 to question number 12. And now in this session, I want us to look at question number 13, and hopefully we'll have enough time to look at all the questions on this paper. So let's quickly go to the paper and start with question number 13. So question number 13, it reads, in the diagram below, A, B, C, and D are points on the circumference of the circle. Center O. DAT, which is angle DAT, is equal to 40 degrees, and BDC is equal to 30 degrees. AT is a tangent of the circle at A. So this question comes from the topic called circle geometry, and before we answer it, there are many theorems and properties of the circle that we need to understand. Now, just to answer this question, I'm going to just talk about briefly just about 5 concepts. I'll talk about 5 concepts that will assist us answer questions on this particular question. All right, so let me just quickly draw the diagram. We have the circle, center there. Then we have the diameter, which is the line passing through the center. This is O. Then we have a chord there. Then we have another chord. This is point D, and that is point A. So at point A, we have a tangent at point A, like that. All right, so this is A. Then we have T. And then we have another chord touching the circumference there, then another chord joining that part. So this is C, that is B, this is 30 degrees. And then we have a line or radius, which is line OA, like that. Then we have line AC, which is a line moving from point A connecting to point C. All right, like that. All right, so angle DAT is 40 degrees, like that. All right, so we have 2 angles. We have angle DAT and angle CDB. So before we answer these 3 questions we are given, we are required to find the angle CBD. Then the other angle we need to find is BAC. And then the last part, or the last angle, is angle AOB. So before we look at these angles, I first of all want to talk about a few properties. The first property I'm going to talk about is the tangent property. Property number 1, tangent property. So when you have a tangent like that, let's call this tangent AC, and then we have the center of the circle, which is O. So let me draw a radius which touches the tangent at point B. So property number 1 is that the angle OBC is equal to 90. So what we are saying is that the line OB is perpendicular to the tangent, meaning at the point of intersection, they form 90 degrees angle. So angle OBC is equal to 90. That is one property. And so is angle OBA. It's 90 degrees. That is the first property. Then number 2, I'll talk about a triangle. I have the angles, interior angles X, Y, and Z. I want you to know that the sum of interior angles in a triangle add up to 180. So what we are saying is that X plus Y plus Z gives us 180 degrees. Then when I draw a straight line, there is a center, let's call it A or B, okay? This is a diameter, okay? It is a diameter. Then you should know that a straight line angle is equal to 180 degrees. You should know that. So straight line angle is equal to 180 degrees. Very, very important property. Then this is property number 3. Then the fourth property I want to talk about angles in the same segment. Okay? So when is a segment formed? For example, when I draw a circle and the chord, this is not a diameter, or it's not a line passing at the center of the circle. It's just passing anywhere or touching the circumference at 2 points. So it is a chord. So when I draw a chord, I form 2 segments. And we are saying that angles in the same segment, they are actually equal. That is a property you need to know. Angles in the same segment are equal. For example, when I draw a line there, like that, this is angle X, and then I also have angle Y, like that. So we can say X is equal to Y, because these are angles in the same segment. So you need to know that property. And maybe the last property I would love to talk about is that the angle at the center is twice the angle at the circumference. That is, let's say we have a circle and we have the center. I draw 2 radii, let's say one there and another one. So I'll call this A or B. Then I draw a chord from A touching the circumference, and another chord from B touching or meeting the other chord at point C, like that. Then we call the angle ACB as theta. Then what we are saying is that the angle at the center of the circle, which is angle A or B, is twice the angle at the circumference, which is, it is twice angle theta. To prove that, we can say we have the circle there, and let's say we have that diagram like that. We want to prove. So let me have A, B, and C. Let me call angle CAB as X, and then angle CB. Okay, so let's do that. Angle CAO is X, and then angle CBO is Y. So when I divide or I draw a radius from O to point C, I form 2 isosceles triangles, and we know that in an isosceles triangle, 2 base angles are equal. So when I do that, then let me call this exterior angle here as A and this other part as B. So meaning that this angle will become X and that will be Y, because in an isosceles triangle, 2 base angles are equal. So we now see that from the diagram here, one exterior angle, which is A, one exterior angle is equal to the sum of 2 interior opposite angles. So will be A is the same as X plus X, which is the same as 2X. And B is also equal to the sum of 2 interior angles, which is Y plus Y. So it will be 2Y. So when I add X and Y, which is the angle at the circumference, I'll have X plus Y, which is one angle at the circumference at point C there, which is angle ACB. Then I also add the A plus B, which is the same thing as 2X plus 2Y. So 2X plus 2Y, and I factor out 2, you'd find that I'm going to have 2 multiplied by X plus Y, which proves that indeed the angle at the center is twice the angle at the circumference. So these are 5 important properties that I want you to know as I solve this particular question. So let's go back to the diagram we drew, which is the question. So using property number 1, the tangent property, we know that angle OAT is equal to 90 degrees. And we are told that DAT, which is angle DAT, is equal to 40 degrees. So subtracting 40 from 90, I will find angle OAD. So we are saying angle OAD gives us 50 degrees because angle OAT is equal to 90 degrees. That's property number 1. So we also know that the triangle AOD is an isosceles triangle because OD is a radius and so is OA. So we have 2 equal distances, okay? And therefore the base angles in this triangle, they are going to be equal. So because of that property, we are saying that angle ODA is also equal to 50, because this is an isosceles triangle and the two base angles in an isosceles triangle are equal. So angle ODA will give us 50 degrees. Now, we also know that the sum of interior angles in a triangle, they are equal to 180. Now, we already have the two base angles, which is 50 and 50. Their sum gives us 100. So when we subtract from 180, we remain with 80. And so angle AOD is equal to 80 degrees. Okay? Is equal to 80 degrees. And we also talked about a straight line angle, which is equal to 180 degrees. The angle DOA is 180 because we have a straight line there. So subtracting 80 from 180, I will get angle BOA as 100. So this angle will be equal to 100. All right. Then let me talk about angles in the angle at the center is twice the angle at the circumference. Now, when we look at angle BOD, it is a straight line angle because I'm considering line BOD, line BOD or line BD. It is a straight line, and we have seen that at the center O it forms 180 degrees. Now we just learned that the angle at the center is twice the angle at the circumference. All right, because this line is dividing the circle into two parts. So the remaining parts or the remaining angles on the circumference of the circle will only be equal to 90 degrees. So because of that, we are saying that angle BCD will be equal to 90 degrees. Okay, angle BCD will be equal to 90 degrees because that angle here at the circumference is half the angle at the center of the circle. All right, so now that we have angle DOA, which is equal to 80 degrees, we know that a straight line angle is equal to 180, and therefore angle AOB gives us 100, because when we subtract 80 from 180, we get 100. So angle AOB is equal to 100. Now I want to find angle BCD. Now, finding angle BCD, I'll use the property that, or I'll use the theorem that the angle at the center is twice the angle at the circumference. And you can see that at the center we have 180, okay? And this line BD is dividing the circle into two equal parts. So meaning that the angles at the circumference or at the remaining part of the circumference will be equal to 90 because the angle at the center is 180. So using that property, then we can say angle BCD is equal to 90 degrees. That is 90 degrees. And so I'll also use the property to find the other remaining angle in a triangle CBD. We know that interior angles or sum of interior angles in a triangle is equal to 180. So I will add 90 plus 30, that gives me 120. And when I subtract 120 from 180, I'll remain with 60. So that will be 60 degrees. So angle CBD is equal to 60 degrees. All right, so using these properties, let's go now to the questions and see if we have the information we need. So you can see that the first part of the question, we are required to find angle CBD. So using the properties of a circle, we have already found angle CBD, which is equal to 60, because angle CBD, let me use a different color, okay? CBD, we are moving from C, we come like that, then we go up to point D here. You can see that we have already found the angle using the property, so it's 60 degrees. Then angle BAC, okay? Angle BAC. So finding angle BAC, I'm going to use angles in the same segment. Remember, angles in the same segment, we said that when you have a chord, then what we are saying is that the angle there, which is Y, is equal to the angle that is formed at the circumference there. So angles in the same segment are equal. So that is the property I'm going to use using this code CB or line CB, you can see that we have the angle BDC, which is equal to 30 degrees, and therefore the angle CAB, this part here, is also equal to 30 degrees, using the property of angles in the same segment. So we have 30 degrees there, meaning that angle BAC is equal to 30 degrees, and angle AOB, we already found angle AOB as 100 after subtracting 80 from 180, we found 100. So angle AOB is equal to 100 degrees. So what I want to say is that in order for you to find answers, or in order for you to calculate angles on the topic circle geometry, you need to understand these properties. You need to understand properties of a circle. You understand many different theorems, and then you apply them to find the angles that you are required to find. So it is important that you take time to look at the properties of a circle and many different theorems that are applied there to calculate angles and other many different problems. There are also properties that talk about calculating the distances, meaning distances of these particular lines that we have. You can take time to look at those things and you will find the question to be very simple. So this is what we needed to do in order for us to answer this particular question. We only needed those five important properties that I talked about in order for us to find this question. So that is what we do. All right, so let's move on to another question. Okay, we move on to another question. If you have questions and comments on this one, you can drop your comments and questions on our Facebook page, MTN Zambia, and we will be able to respond to you. All right, so we go to question number 14. Question number 14. All right, so question number 14. In the diagram below, BCD is a straight line. AB is 12 centimeters, AC is 20 centimeters, and angle ABC is equal to 90 degrees. Then we are given the diagram there. Question number 14, part A. We have the diagram. All right, so this is A, B, C, and D. Then we have the hypotenuse, which is 20. Then we have 12 there, and we have 90 degrees at that point. So now the question is, you find the value of cos ACD. So we find the value of cos ACD. ACD is the angle, so we are looking at the cos of the exterior angle, which is outside. So to find the cos of the exterior angle, let me draw another diagram. This is a right-angled triangle ABCD, like that. So I'll call this part as theta, and then I'll call the exterior angle as alpha, like that. So this is the hypotenuse, and this is opposite, because it is opposite to theta, and then I'll call this line BC as their D, the adjacent side. Or we can just use the distances of these lines. So using the trigonometric ratios, I love using the mnemonic SOHCAHTOA, which is very common. SOHCAHTOA. So S is for sine. So we say sine of an angle. So you can see in the question, O is opposite. So O is opposite to the angle theta. So I'll use sine theta is equal to opposite divided by H is the hypotenuse. So you divide by H. Then C, this one, K in the mnemonic SOHCAHTOA, we have C there, which is for cosine. Then we have theta is equal to adjacent, which is A divided by H. And then the last ratio that we can look at is tangent, which is tan theta is equal to, this T is equal to opposite divided by adjacent. So to find the cosine of theta, I will use cos theta is equal to adjacent divided by hypotenuse. Then to find the cosine of the exterior angle, I just need to multiply the right hand side by -1. By -1, multiplied by -1, which gives me -a over h. I need to change this part. Oh, yeah, this is alpha, because we are calculating the cos of an exterior angle. Okay, all right. So this one is the cos of the interior angle, which is theta, and then this, the second one, cos alpha, is the cos of the exterior angle. So I'm multiplying by negative. Now the question is, why am I multiplying by negative? Now what you need to know is that theta is an acute angle when you look at the diagram. And when I find the value of that acute angle, I can subtract it from 180 in order for me to find the same angle in the second quadrant. But what we know is that cos in the second quadrant is negative. And when you look at the exterior angle alpha, when you look at the exterior angle alpha, this part here, you realize that this alpha is an exterior angle. So what you can do is you can subtract from 180, or you can just simply multiply the ratio of the adjacent to the hypotenuse by -1 in order for you to find the cos of an exterior angle. So the way this particular question was supposed to be solved is, first of all, because it is cos, we needed to find the distance BC. The distance BC, which is this part, we don't know it. So we'll use Pythagoras theorem to find BC, and then we'll come and use the trigonometric ratios cos to find the value of an interior angle ACB, which is this part, and then we'll use the property I've just given you to find the cosine of an exterior angle. So using Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the squares of the two adjacent sides. So what we are supposed to do there now is, this is A, B, C, D. So this is 20 and we have 12. Then first of all, we are supposed to calculate the value of BC. So let me change the color to black, which is more visible. So the square of AC is equal to the square of AB plus BC squared. So AC is 20 squared, then AB is 12 squared, then we'll have plus BC squared, then BC will be equal to, that is making BC the subject of the formula, it will be equal to the square root of 20 squared minus 12 squared. Of course, I just transposed 12 squared, I transposed it, so it became 20 squared minus 12 squared, and then I remained with BC. Then I square rooted both sides of the equation for me to make B the subject of the formula, BC the subject of the formula. So BC will be equal to square root of the square of 20, that is 20 times 20, you'll get 400, minus 12 times 12, you get 144. All right, so when you look at the radical, which are these numbers under the square root, you will see that we have BC is equal to root of 400 minus 144. And so when I simplify, I have 400 minus 144, that will give me 256. Then when I find the square root of 256, that will give me 16. I'm just considering positive 16 because BC, we are talking about distance. So we can't consider negative 16. We are just considering positive 16 because we're talking about distance here. So BC is positive 16. So I've found BC, which is 16. So since I have BC, I'm now going to find the cosine of ACB first of all. So the cosine of ACB will be equal to adjacent is a 16, divided by the hypotenuse, which is 20. So simplifying that, cos of ACB, which is an interior angle, 2 into 16, okay, let me use 4. 4 into 16, I'll get 4. and 4 into 20, that is 5. So ACB is an interior angle. ACB is this part, which is an interior angle, and in the question I'm looking for ACD, which is an exterior angle. So I will multiply the right hand side, which is 4 over 5, by -1, and therefore cosine of ACD, angle ACD, all right, which is an exterior angle, this part here, that is the one I'm talking about, ACD, it will now be equal to the right hand side of this equation will be multiplied by -1, so I have -4 over 5. So I'm multiplying by -4 over 5 because this is as good as finding the angle in the second quadrant where cosine is negative. Okay, so in paper 2, for example, if this question was in paper 2, we could have found it, or maybe we could have calculated the value of cos of ACB is equal to 4 over 5, and then when we find the angle, because it's interior, we are looking for the exterior, we subtract from 180. So you see that 180, in 180 cosine is negative because in the first quadrant it is positive, in the second quadrant it is negative. And the exterior angle we are looking for is not an acute angle, it is above 90 but less than 180. So it's within the principal axis from 0 to 180 degrees. So angle or cosine of angle ACD is simply equal to -4 over 5. That is what they were looking for. So what we need to know here is, or the key concept that we need to get here is that when you find cosine of the interior angle, okay, if cosine of the interior angle is equal to A, then cosine of the exterior angle is equal to -A. All right? Okay, fine. So that is the solution for question number 14. Question number 14. All right? Question number 14. And this is part A. All right. So let's go to question number 14, part B. Question number 14, part B. So question number 14, part B, it reads, A and B are points with coordinates. So A and B are points with coordinate -3, 3, and 5,9 respectively, meaning that the coordinate of point A is -3, 3, and the coordinate of B is 5,9. All right? So the question is find the length of AB. Now, we want to find the length of AB given 2 points. So, let me draw a diagram before I explain anything. Let's say we have a line AB like that. So, point A in the x-axis, this is point X, and then let me call that point X1, and then point B, we move from X to point X2. Then in the y-axis, point A, this is Y1, and then in the y-axis for point B, that will be Y2, because we have moved from Y, we have moved a certain distance, so we'll call that Y2. So let me also connect the line from point A to another line, or to this line which is perpendicular to the x-axis at X2, and I'll call that E. So now, the distance AE is the difference between point 2 and point 1 in the x-axis. So AE is equal to X2 minus X1, and then BE is equal to Y2 minus Y1 when you find the difference there in terms of distances. And so if I have to calculate the value of AB, or the distance of AB, I will use Pythagoras theorem. So using Pythagoras theorem, we are saying that AB squared will be equal to, I'll get any adjacent side there, so we can say X squared minus X, or let's say X2 minus X1, I'll square it. Then minus Y2 minus Y1, I'll also square it. So this is Pythagoras theorem, and therefore AB will be equal to the square root of X2 minus X1 squared minus y2 minus y1 squared. So this is the formula we use for calculating the distance between 2 points. Okay, so let's say we have been given point A is negative 3,3 and B is 5,9. So I will label the first coordinate x1, y1 and the second coordinate x2, y2. So substituting these coordinates in the formula, this one I'll call it star 1, we are going to have AB is equal to the square root of x2 is 5 minus x1 is minus 3, then I'll square that, then minus, plus Pythagoras theorem, so it's supposed to be plus there and also plus there, it's Pythagoras theorem we are talking about. So we'll have 5 minus negative 3 squared plus, then y2 is 9, then minus y1 is 3, then I'll also square that. So simplifying this one, I'll have the square root of 5 minus minus 3, I'll get positive 8 squared, then plus 9 minus 3, that gives me 6, I'll square that, then I'll have 8 squared, that is 64, plus 6 times 6, I'll have 36, then that would be square root of 64 plus 36, that gives me 100. And the square root of 100, it is 10. Because I don't have units there, I can just put 10 units. Of course, I'm not going to put negative 10, okay, because I'm talking about BC, which is the distance, okay, of a line segment. So we are still talking about distance. So we can't include a negative value there, okay. Yeah, so it will be 10 units. If let's say the distances we are given in centimeters, I could have said it is 10 centimeters. But because we have no units, you put just units there to mean distance, okay. So the answer here, or the length of a line segment AB is equal to 10 units. So that is how question 14B was supposed to be solved. All right, so before we go to question number 15, let's just pause for a short break. Stay tuned.
Okay, let me know how it goes.
I will. I need to go now.
And don't forget to check up on your brother.
Ziba mami, I will. I really need to go. Nizachedwa.
And also wish your dad a happy birthday.
Bye. Ish, my mom. She never stops talking, but I'm not complaining because I love our conversations. And MTN's 777 Just For You makes life and communication so much easier. Especially for a student like me, cause sinisebenza just yet. So, with 777 Just For You, I get special discounted data and voice bundles that allow me to do my schoolwork with ease and keep up with the latest trends online. I get to call my family and friends, plus there's also a gift folder. To cut the long story short, I talk more and browse longer. That's my mom. I better video call my dad and brother before class. MTN gives you so much more with 777 Just For You. Enjoy amazing day and night bundles, super fast 4G data bundles, Loco Nilaka, and more. Plus, you also get a special gift from us. Simply dial star 777 hash and select an offer of your choice. Sekelela, we are on your side.
MTN.
Welcome back to the program. Just before the break, we looked at question number 14, and now let's look at the rest of the questions starting from question number 15. All right, so question number 15, it reads, A varies directly as B and the square of C, and A is equal to 30 when B is equal to 2.5 and C is equal to 2. Find A, the value of K, which is the constant of variation. Then B, find the value of A when B is equal to 2 and C is equal to 3. Then part C, values of C when A is equal to 300 and B is equal to 4. All right, so variation. So the first thing that we are going to do is to change this statement we are given or transform it into a mathematical statement. So question number 15, we are told that A varies directly as B and I'll use multiplication there and the square of what? C, which is just the same as A varies directly as B and the square of C. So when I change, or when I replace the variation symbol, this sign, variation symbol or the symbol of proportionality, I replace it with an equal sign, then I will multiply the right hand side by a constant of variation, which in this case I will call K. So this is the same thing as A is equal to, then K multiplied by B C squared, which is A is equal to K B C squared. So now I'm going to solve the first part of the question, where we are looking for the value of K, which is the constant of proportion. So in the question, I've been given that A is equal to 30, and of course B is 2.5, then C is equal to 2. So I'll use these values to find the value of K in what I may call equation 1. So from equation 1, making K the subject of the formula, I will have K is equal to A divided by B C squared. All right. Then I will substitute the value of A is 30, then B is 2.5, and then C is 2. So all I need to do is just to simplify that. So I'll have 30 divided by, also C is squared there, so it will be 2 squared. So this will give me 2.5 multiplied by 4. And this will now give me 30 divided by, now 2.5 multiplied by 4. It's like adding 2.5 by itself 4 times. So 2.5 plus 2.5 plus 2.5 plus 2.5. So 2.5 plus 2.5, that is 5. 5 plus 2.5, you get 7. And 7 plus 2.5, you get 10. So 2.5 times 4 gives us 10. And then 10 into 30, that is 3. Therefore, the constant of variation or constant of proportionality there is equal to 3. So K is equal to 3, which is the constant of proportion or constant of variation. So now that we have the value of K, which is part A, I can now rewrite equation 1. This part I can rewrite it and substitute the value of K with 3, and therefore the equation connecting A, B, and C will be A is equal to 3B C squared. So I'll be using this equation to solve the rest of the questions. So part B, I'm looking for the value of A when B is equal to 2 and C is equal to 3. So A will be equal to 3 multiplied by 2, then multiplied by 3 squared. So this will give me 6, then 3 squared, that will give me 9. And then 6 times 9, that gives me 54. Therefore, the value of A will be equal to 54 when B is equal to 2 and C is equal to 3. Then we solve the last part, which is part C. Part C will still use the equation connecting A, B, and C, which is A is equal to B C squared. We are looking for the value of C when A is equal to 300, then B is equal to 4. So A, I'll substitute that with 300. We have 300 is equal to 3. B is 4. And then C squared. So this will be 300 is equal to 3 times 4, I'll get 12. And then C squared. So making C the subject, I'll divide both sides by 12. And I'll get C is equal to. Now, dividing 12 into 30, or if you like, you can just simplify it. Okay, you can simplify that by saying how many times can 2 go into 12, how many times can that go into 300. So what we are saying is that simplifying or dividing 12 into 30, 12 into 30, okay, that will just give us 2, because it goes in 2 times 12, it's 24. So that will be 2 times, and then a remainder 6, okay? Then 12 can go into 65 times. So 12 into 300, that is 25, and then this is c squared. So to calculate for the value of c, now we are not talking about distance, we are just talking about the value of c. So this gives us the difference of 2 squares, okay? And because of that, we can rewrite this one by saying c squared will now be, when I transpose 25, I'll have minus 25 is equal to 0. And then I can rewrite that equation by saying c squared minus, I'll write 25 as 5 raised to the power 2 to make a difference of 2 squares. And then this means is that the left hand side, I can write it as c minus 5, open bracket c plus 5, which gives me equal to 0. So since this is the product of two factors or product of two terms, which gives me 0, then it means that either one of them is equal to 0. So either c minus 5 is equal to 0 or c plus 5 is equal to 0. So solving for c, we have c is equal to 5 or c is equal to negative 5. Therefore, the value of c is equal to positive or negative 5. And that is the answer for part C of question number 15. All right, so we move on to question number 16. Question number 16, it has two parts. The first part of question number 16 is find the integral of 3x squared plus 8x minus 5 dx. Now, let me talk about general differentiation and general integration. Now, to integrate a function, it simply means that we are taking it back to its general form. For example, if you have y as a function and then you differentiate y, when you integrate the derivative of y, then you are going to have the function y. So it's like the reverse process of differentiation. So let's say y is equal to a raised to the power x n, then y prime is the same thing as a times n x, then the n will be subtracted by 1. So if I have to integrate now this same function and take it back to its original function, which is y star 1, then the integral of a n x n minus 1 dx will then be equal to, so it will be 1 divided by the power of x, which is n minus 1. I will add that by 1. Then multiplied by a n x n minus 1. So the power again of x, which is n minus 1, I will also add that by 1. So I'm adding. When I'm integrating, I'm adding. So when I simplify that, you will see that this will give me 1 over, then n minus 1 plus 1, that just gives me n. Then I'll have a nx, and then the power will just be n. So when I multiply 1 over n multiplied by a n x raised to the power n, so this one will go and that n will go, and therefore I'll just remain with a x raised to the power n. So I've gone back to the original function, which is star 1 here, which is y is equal to a x raised to the power n. So what we are saying is that integration is the reverse process of differentiation. So I'll be using the same method to differentiate or to integrate the terms that I'm given in the question. So our question is squared plus 8x minus 5, all right, then dx. So this will give us the integral of 3x squared dx plus the integral of 8x dx, then minus the integral of 5 dx. Then integrating the first part, I will have 3 over 3x raised to the power 3 plus 8 divided by 2 x raised to the power 2 then minus the integral of a constant, you just multiply that by the variable x. All right, and then I'll simplify that. 3 into 3, that will just give me 1, so the first term will be x cubed, and then plus 2 into 8, that gives me 4, then I have x squared minus 5x. Now, since this is an indefinite integral, then I'm supposed to add a constant. Okay, I'm supposed to add a constant. You can use c or you can use k. That is the constant of variation because it is an indefinite integral. The reason why we add indefinite integrals by a constant c, we add a constant c there, it's because when I differentiate, we know that the derivative of a constant is equal to 0. So we are assuming that in order for us to remain with a function that we had, then there was a constant somewhere which was differentiated and we got a 0. That's why we have to indicate that there was a constant by just using a variable c, or you can use k. So the answer for part A of our question is x cubed plus 4x squared minus 5x plus c. That is the answer for question number 16, part A. All right. So let's go to question number 16b. Question number 16b. The question reads, the diagram below shows two triangles A and B. And so I will try to actually draw this diagram here, but I will not draw it the way it looks in the question paper. I will just draw the x or y plane. X or y plane like that. And let's see. Okay. And then we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Then we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6. -1, that is 0, -2, -3, -4, -5. We have 1, 2, 3, 4, 5, 6, 7, and 8. So the first diagram is 2, 1, and then 4, 1. Then we have 4, 4. Okay, so roughly this diagram is like that, which is A. And then we have B, which is, okay, so we have -2, 3. So at that point, then we have -4, 3, and then we have -2, 6 at that point. So roughly the other triangle, which is triangle B, looks like that. Now, this question comes from the topic called transformation. Okay? Now, transformation is actually the geometrical process of mapping a plane figure onto another. Okay? Or we can call it a geometrical operation where a plane figure is mapped onto another. So that plane figure I'm talking about is the object, and the another in this context we are talking about the image, which is another object. So when you read the question, you will see that the question down there, they are saying we need to describe fully the single transformation which maps A onto B, meaning A is the object and B is the image, because transformation is actually a geometrical operation of, or it is a geometrical operation of mapping a plane figure onto another. Okay, so in transformation we are saying a plane figure is mapped onto another, and that plane figure is what we are calling the object, and the another in this context is the image. So in the question we are saying triangle A is mapped onto triangle B, meaning A is the object and B is the image. Now, transformation is categorized into 3. There are 3 categories. The first category is called isometry. And under isometry, we are talking about transformations where the size and the shape is preserved. Okay? The size and shape is preserved. Then we are talking about isometries. When we talk about transformations where the shape is preserved, but the size is not preserved, then we are talking about similarities, which is the next category of transformation. Then we have the last category, which is called affines, where we have both the shape and the size is not preserved. In affines, we have stretch and we have shear. In similarities, that is where we have enlargement. So enlargement, you see that the shape will be maintained, but it will either be magnified, it will actually grow, it will become big, or it will become small. And then we have isometries where the shape is maintained and also the size will be maintained. And the examples of transformations under isometry, we have rotation, translation, and we have reflection. So we can see that in the diagram here, we are dealing with a triangle of the same size. So the shape and the size has been maintained, and therefore I'll focus on the isometries, which is the first category. Now, let's talk about reflection. Definitely, you will see that the way the diagrams are, obviously when I use the y-axis as a mirror line, it won't really make sense. It won't look like reflection there. So reflection is out. When we talk about rotation, the diagram does not look like it has moved. Okay? It doesn't look like it has been thinned. So we cannot talk about rotation. But let's talk about translation. Translation, we are talking about translation as a transformation, okay, which can also be looked at as a vector, okay? We can look at a translation as a vector because it has direction and it has also magnitude, all right? So when you look at the diagrams here, you will see that it's like the triangle A has just been moved in a certain direction, okay? It has just been moved in a certain direction. It has not been turned. It is the same thing which has been moved from the position where it is to a different position. So we are talking about a translation here. That is a transformation that we are talking about. And now when I talk about corresponding points from the object to the image, let's say I join the two. I join the corresponding points, which is connecting that point from triangle B to triangle A, and then I also connect from that point to that. Don't worry about my lines, of course, I'm just using this for illustration purposes, and then I connect those two points there also from the object to the image. You will see that the points from the object to the image, they are moving in equal distances, okay? And the lines connecting points from the object to the image, they are parallel to each other and they are also equal in distance. So how do you find a translation in this case? The job here is just to describe this transformation fully. And I mentioned that we are going to look at a transformation as a vector which has both magnitude and direction. So we can say a translation, I'll use T, will be looked at as a vector like that, which is a column vector. And a translation is given by points on the image. We'll call that x2, y2. These are points on the image. Then you subtract by a corresponding point from the object, which is x1, y1. So let me pick 2 points. Let me use a different color there. So from the object, I will use this point and that point. So this is point number 1, and I'll call that point number 2. Okay? So this is the point from the image, corresponding point from the image and object. So to find the translation vector there, what I'm going to do is it will be AB will be equal to, now the point on the image, it is negative 4,3. Huh? Negative 4,3, so negative 4,3 in form of a vector, it will be like that. And then the point on the object, that is 2,1, 2,1. So let me use color. So this is displacement. We are talking about displacement in the horizontal axis, and then this is displacement in the what? Vertical direction. So then simplifying the right hand side, we'll have negative 4 minus 2, that gives me negative 6, and the 3 minus 1, that gives me 2. And therefore, describing this transformation fully, we can say it is a translation. It is a translation with vector -6, 2. So it means that you have described your translation fully. So what that means is that each point from the object to the image, okay, it is moving, okay, 6 times to the negative side, okay, and also 2 times to the, it is moving 6 times to the negative sides in the horizontal axis, and also 2 times in the vertical, in the vertical axis, of course, 2 times in the vertical axis. So we're talking about displacement there. So you can see when we look at the diagram here, you will see that when I talk about point A, when we calculate the displacement, which is the distance in the horizontal axis and the distance in the horizontal axis, let me show you that. Let me show you. We have from point 2, distance in the horizontal axis, so assuming that it's distance in the vertical like that. So you will see that moving from positive 2 to -4, I'm moving 6 times to the negative side, and moving from -1 to +3, I am moving 2 times in the horizontal axis. So that is what we need to picture when we are talking about a translation there, or move or displacement in the horizontal direction and displacement in the vertical direction. All right, so that is the answer for question number 16, part B. The answer is -6 to there, which is the vector of a translation. All right, so let's quickly move on to another question, which is question number 18. All right, let's talk about question number 18. We'll talk about question number 18. Question number 18A. Question number 18A. The diagram below shows a plane figure made up of congruent semicircles. Then angle AOB is 90 degrees. So the question is that we need to describe fully the symmetry of the figure. So we are talking about rotational symmetry, and we are given the angle AOB that it is 90 degrees. In other words, okay. So in other words, we are saying that you are supposed to make a turn of 90 degrees in order for you to get the same shape. Okay, so to calculate order of rotational symmetry, what we are supposed to do there is that we have to look at the total number of degrees for a complete turn is actually 360 degrees, and we are told that the angle AOB is 90 degrees. And you can see that when I make a 90 degrees turn, I am actually attaining the same shape. So that is rotational symmetry, okay? So I'm looking for the order of rotational symmetry. I'll divide 360 by 90 degrees, and you see that 90 will go into 360 4 times. All right? So now I need to describe this rotational symmetry, or order of rotational symmetry. So we can say that there is what? Order, or we can say this is rotational symmetry, of order 4. Then it means that we have described the order of rotational symmetry fully. We are supposed to say order of rotational symmetry, or we say rotational symmetry of order 4. In fact, you should continue and say it is rotational symmetry of order 4 about the origin O. Or you can just add that and say about O. Then it means that you have described the order of rotational symmetry fully. All right, so we go to part B. Part B of question number 18. Part B of question number 18. Part B of question number 18. In the space, or in the answer space below, is an incomplete program written in pseudocode for calculating the volume of a cuboid. So we know that volume of a cuboid will be given by L times B times H. Okay? And then given that the length L, B is the base, and H is the height, complete the program by filling in the blank spaces with appropriate statements. So we have been given the program down there. We have begin, then there is enter. So after enter we have volume is equal to, then there is output, which is V, and then the program ends. So what we know is that volume of a cuboid is given by L times B times H. But since we are talking about a program, this is a pseudocode, and we are using an algorithm. It's an algorithm, and we are using pseudocode to actually represent or present this algorithm. So we know that in computer programming, the symbol for multiplication, this one, it does not apply. We use a star to mean multiplication. That is in programming. So meaning that when I enter the values of length, breadth, and height in the program, then the first part here will be L. I will separate those values using a comma. Okay, and then okay, just I think I've made a mistake there. Okay, let me just rub that part. So this is supposed to be, there's a dash there. All right, like that. Okay, good. So I will enter L. All right, I will separate that using a comma, and then the program will process. Now when it processes to calculate volume, it will start multiplying those values I've entered, and so that will be L, then times using a star. You use a star to actually mean times or multiplication, B, then H. So when you do that, when you enter the values of length, breadth, and height, the program will process that, it will multiply, and then it will give you an output of volume. Okay, and then the program will end. So that is basically what you just needed to do on that one. So let me just solve the last question before I wrap up, and that is question number 19. So question number 19 is under functions. All right, so we are given two functions. We have been given f of x is equal to 2x minus 3, and then g of x is equal to 3x. So the first part is that we are required to find the inverse of f of x. So we know that f of x is equal to 2x minus 3. So we let f of x be equal to y, then y will be equal to 2x minus 3. So making x the subject of the formula, we are going to have 2x is equal to y plus 3. Dividing both sides by 2, I'll have x is equal to y plus 3 over 2. And therefore, f inverse, so you just need to change the x to f inverse of x, and then on the right side, wherever there is y, you replace y with an x, so it will be x plus 3 divided by 2. So that is the inverse of the function of x, or the function f of x. Then we go to part B of the question, g f of x. So g f of x is a compound function, or we can also call it function of a function. And g f of x, what it means is that you have the function g, and f of x is supposed to be the object of the function g. So it is a function of a function. So I'll actually replace f of x by the function, which is 2x minus 3. We are given g there, so I'll replace f of x with 2x minus 3, like that. And then I'll look for g of 2x minus 3. Now we know that g of x is equal to 3x. So when I replace x with 2x minus 3, then on the right hand side of this particular equation, I'm also supposed to replace, wherever there is x, I should replace that with 2x minus 3. Then simplifying the right hand side, I'll have 3 multiplied by 2x, I'll get 6x, then minus 3 times 3, I'll get 9. Or positive 3 times negative 3, I'll get negative 9. And therefore, we are saying that g f of x, gf of x is equal to 6x minus 9. Okay, so for part C, we already have the expression for g of f of x, which is equal to 6x minus 9. Now we are required to find gf of 2. All right, so I already have gf of x, which is equal to 6x minus 9. So substituting x by 2, I will have g f of 2 is equal to 6. Then I'll replace that x with 2 minus 9. Then 6 times 2, that gives me 12 minus 9. And then 12 minus 9, that gives me 3. We will get 3, positive 3. Therefore, the gf of 2 will give us positive 3. And that is how you answer question number 19, part C. All right, Dad, so this is where we come to the end of our second session. I hope you learned quite a lot of things. My name is Chimpusa Kasonde. Until next time, goodbye.
Tiende pamoja ni mtima umo. 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 Tiende pamoja ni mtima